Hello, everyone. I'm Toby Lee from CMU. It's my great pleasure to talk about our work in multimodal repairs of conversational breakdowns in task-oriented dialogues. This work is done with my colleagues from CMU and UC San Diego. There are different types of breakdowns in human-agent conversations. In this paper, we specifically focus on the natural language understanding errors in task-oriented frame-based agents. In frame-based agents, when the user sets a command, the agent detects an intent, which is the type of the task. From the command, such as search for flights, each intent requires a set of slots, such as the airline, the source, the destination. The agent will try to extract the values for these slots from the user's command. If any of the slot values is unknown, the agent will ask about them in the conversation. This paper discusses three common types of errors in this process: fail to detect the intent, error in intent detection, where the system detects the wrong intent, and error in slot extraction. For example, here it misrecognized the word Singapore from Singapore Airlines as a departure city. We use the grounding theory in communication to understand human-agent interaction, where the user and the agent each has some knowledge, beliefs, and assumptions. The goal of the communication is to establish a common ground of mutual knowledge, beliefs, and assumptions. A key challenge is that the user needs to understand what the agent knows through evidence. For example, if the agent's response to a user command is, "Sorry, I don't understand," it's not very useful and offers little insight into what the agent already knows. The second challenge is, after the user understands what the agent knows, there might be a misunderstanding. The user needs to find an effective strategy to fix the misunderstanding. Prior studies have shown that when the agent acts on misunderstanding and performs the wrong action, the user is often not able to find an effective conversational repair strategy because of their lack of understanding of the source of the error. One effective way to address these two challenges is to have domain-specific fallback conversations like these. However, it requires manual design, which is not scalable and therefore not widely used in current agents. We present SOVITE, a new interface for conversational breakdown repair that uses a multimodal approach that leverages the GUI screenshots of existing apps. It builds upon our open-source SOVITE agent and can help users discover, identify, and repair conversational breakdowns in various task domains without requiring manually created conversation flows for error handling. The first key step is to show a user the agent's state of understanding. SOVITE shows screenshots of a relevant app, as that's what I would do if I were to use this app to perform the task. This approach provides good closeness of mapping to how users perform the task themselves, allowing them to easily discover errors. If SOVITE shows a wrong screen or a wrong app, that indicates an intent detection error. When the app is wrong, the user can simply tell the agent which app to use. When the screen is wrong, the user can navigate to the right screen in the app and demonstrate the screen. It's worth noting that SOVITE not only searches for intents that use exactly the same apps and screens, but also those that are semantically similar. If the highlighted slot values are incorrect, there's a slot value extraction error. As you can see here, if the slot value is from a menu in the app, the user can simply drag the highlight overlay to choose the right slot value. In text entry type slots, the user can fix the value using gestures or speech. Finally, if the slot values are mismatched, the user can just drag to swap their values. There are three key points in our design rationale. First, we try to bridge the interdependent gulf of evaluation and gulf of execution by making how users identify breakdowns consistent with how users repair breakdowns. Second, we use the mutual disambiguation pattern in multimodal interaction by having the user direct manipulate GUIs to disambiguate their spoken natural language inputs. Third, we use the apps and app screenshots as a medium to help grounding the user's unrestricted natural language inputs to something that both the user and the system are familiar with. We conducted a usability evaluation where 10 users tried to use SOVITE in 7 example scenarios. The study was conducted through Zoom screen share due to the COVID-19 pandemic. The results are positive. Our participants successfully identified all the no-error scenarios and fixed 95% of the error scenarios. They also reported that SOVITE was helpful and easy to use in a post-study questionnaire. You can refer to the paper for details on the result. That brings us to the end of my talk today. This work is a part of our SOVITE project on programmable intelligent agent. You can find the other papers here and also on my website. By the way, I'm on the job market right now, so hit me up if you know a position. Thanks.